Hello, dear students. This is Vijay Lakshmi. Welcome to WinMaths YouTube channel. Here, this session, we will discuss the concept continuity and differentiability. Okay. Here, this YouTube channel helping students across Karnataka to excel in their PUC board exam and competitive exam. In this session, we have to discuss the concept differentiability because we already learned in last session that it is continuity, and based on the continuity we solve the problems also. Okay, now the differentiability. Okay, here every continuous function is differentiation. Okay, every continuous function is differentiation. Okay, here differentiability means, suppose f is a real function and c is a point in its domain. The derivative of f at c is defined by limit x tends to 0 f of c plus h minus f of c divided by h. In generally, what we return, that is f dash of c. Okay, the function f dash of c is equals to limit x tends to 0 f of c plus h minus f of c divided by h. Here there is a function, both are continuous function. Here c is a points in its domain. Then derivative can be defined like this, that is f dash of c is equals to limit x tends to 0 f of c plus h minus f of c divided by h. Usually, differentiability can be denoted by usually differentiability can be denoted by f dash of c, or otherwise it can be written as d by dx of f of c. Okay, it can be written as d by dx of f of c. Then for replacing xc by x here, it can be written as limit, okay, f dash of x. Okay, here f of x dash or f dash of x is equals to limit x tends to 0 f of x plus h minus f of x divided by h. Sometimes it is can be written of the form f dash of x, or it can be written as y dash, because if y is equals to, we will take f of x. Okay, here we have taken y is a function, y is equals to f of x, then differentiate with respect to x. Differentiate with respect to x. Then we can say d by dx of y is equals to, when differentiation, it undergoes f dash of x. Okay, therefore it can be written as differentiation of y is dy by dx and f dash of x. Okay, the process of finding derivative of a function is called differentiation. The process of finding derivative of a function is called differentiation. We also use the phrase of differentiation of f of x with respect to x. Differentiate with respect to x. It means f dash of x. Here I am taking the equation. Okay. Here let y be a function. I can written y is equals to f of x. Okay. Here taking differentiation. Okay. Here taking differentiation with respect to x. We already known as differentiation of y. That is, it can be written as d by dx of y is equals to differentiation of f of x can be written as f dash of x. Here x is, okay, here in this function d by dx represent, okay, depend. Okay, it is dependent. Then it is independent. Okay, here it is dependent and independent. Okay, based on this one concept, we will define the differentiation. Okay, let us move on the concept. Okay, there are some rules are there. Okay, there are some following rules were established as a part of algebra of derivatives. Okay, here that is first one is u plus v whole dash is equals to u dash plus or minus v dash. Again, there is a second one formula, that is product rule, and the next one is quotient. Okay, these are the basic rules for finding the derivatives. Here, u and v. Here, u and v are two functions. Okay, here u and v are two functions. Okay, when they given the two functions, okay, we have considered the two functions u and v, then differentiation. We have to separate differentiation, then give addition or subtractive symbol. Okay, we can differentiate separately. Okay, here u plus or minus v dash is equals to, separately we can written u dash plus or minus v dash. Okay, here in this second product rule, here there are two functions u and v, both are two functions. And then what we do, first have to differentiate u function. First function have to differentiate, then keep second one as a constant. Keep second one as a constant. Again, then plus. Okay. Then keep it as second function differentiation. Here, second function differentiation and function will be same. Okay. Now, in that product rule, or here that is quotient rule. Here it is quotient rule. Here there are two functions, okay, of the form u by v. Two function of the form u by v whole differentiation. What can be written? First, have to differentiate the first function and keep second function as a constant, minus, and differentiate the second function, then keep it constant as a first function, then square of the second function. Square of the second function. This is called the quotient rule. Okay, we will discuss these three rules while solving the problems. Okay, next, list of derivatives. Okay, these are the basic common list for finding the derivatives. It means differentiation of x to the power n. Okay, here y is equals to x to the form of n, then we take differentiation. Here d by dx of x to the power n, we can written as a n into x to the power n minus 1. For example, I will consider x square. Okay, here x square is a function, then differentiation is equals to 1. Take differentiate with respect to x. Okay, then I can written dy by dx. Here x square of, replace n by 2. What we written in the differentiation? First 2, okay, x to the power 2 minus 1. Then it is 2 into x to the power 1. Okay, this is the differentiation of x square. Okay, therefore the general formula for differentiation of x to the power n is n into x to the power n minus 1. Okay, again, similarly, again, similarly for differentiation of sin x. Differentiation of sin x will be cos x. Differentiation of cos x is minus sin x, and differentiation of log x is equals to 1 by x. Differentiation of root x will be 1 divided by 2 into root x. Differentiation of tan x will be sec square x, and differentiation of constant. Okay, it means differentiation of anything, the numbers. That is, I will take one example. Here y is equals to 2. Okay, it y is equals to 2. It means the function does not containing any x coefficient. Okay, the function does not containing any of x. Okay, here the x power will be 0. Therefore, there is no x. That's why the function is constant. Otherwise, sometimes we will say the constant function, there is no replacement of the function. Okay, that time the differentiation of constant will be 0. Okay, next we will move on the problems. Okay, here there is a one example. Find the derivative of f where f of x is equals to 2x plus 1 whole to the power 3. Now, consider the function. Here f of x is equals to 2x plus 1 to the power 3. Okay, now differentiate with respect to x. Okay, I am taking here we don't have any formula, because check here. Okay, check here, we don't have any formula related to that. 2x plus 3 whole to the power 3. Okay, that's why I'm taking here. That's why I'm taking of the form. Take 2x plus 1 as a x. Okay, I will consider take 2x plus 1 as a x. That is f of x is equals to, okay, that is take it as a x plus 3. Okay, now differentiate with respect to x, because we know that the formula x to the power n. Okay, what is the differentiation of x to the power n? What is the differentiation of x to the power n? That is n into x to the power n minus 1. Therefore, replace. Okay, replace 3n by 3. 3 into x to the power 3 minus 1. That is 3x square. Okay, differentiation of x cube will be 3x square. Okay, that is f dash of x is equals to x to the power 3 into x square. Here, our x will be 2x plus 1. Therefore, again I will replace f of x is equals to 3 and x square as common, 2x plus 1 whole cube. Sorry, whole square. Then, again, here x is not there. That's why in that function I will take again 2x plus 1. Okay, differentiation of 2x. 3 into 2x plus 1 whole square. Differentiation. Okay. Here 2x is polynomial function, 1 is constant function. Here there is a plus symbol. I will take separately. Okay. D by dx of 2x plus d by dx of 1. That is equals to 3 into 2x plus 1 whole square. Differentiation of 2. 2 will be constant. I will keep it here. Differentiation of x with respect to x. That is 1. Okay. We know that differentiation of x to the power n. Here n is 1. X to the power 1. Therefore, differentiation, what is that? 1 into x to the power 1 minus 1. That is 1 minus 1, 0. x to the power 0 will be 1. Therefore, differentiation of x is 1. That's why I am writing 2 into 1 plus 1 is a constant, differentiation of constant will be 0. Now I will multiply here 3 into 2, 6, 2x plus 1 whole square. This is the differentiation of the given function f dash of x is equals to 6 into 2x plus 1 whole square. Okay. Now let's discuss the next one problem. Next one example. Okay. I will take the next one example here. Okay. Okay. I will take another one example here. F of x is equals to x to the power 7. Okay. Now differentiate with respect to x. Okay. Here differentiate. Here differentiate with respect to x. Here differentiate with respect to x. So f dash of x is equals to x to the power. Here we know that the general formula x to the power n, differentiation of x to the power n will be n into x to the power n minus 1. Okay. Here the function is x to the power 7. Replace n by 7. We get 7 into x to the power 7 minus 1. Okay. Here. Okay, I will return 7 into x to the power 7 minus 1 is equals to 7 into x to the power 7 minus 1, 6. This is the differentiation of f dash of x. Okay. Now, again, I will take another one function. I will consider f of x is equals to sin x plus cos x. Okay. Here, sin x and cos x are two functions. Here, sin x and cos x are two functions. I can differentiate. I can differentiate with respect to x. Okay. Here, this is one function. This is one function. Now, f dash of x is equals to, I will take sin x as the first function separately, d by dx of sin x plus, keep it plus sign, and differentiation of cos x. Okay, I will differentiate separately. Now, differentiation of sin x, we already know the standard formula, that is cos x, and differentiation of cos x will be minus sin x, that is equals to cos x minus sin x, because plus into minus minus, differentiation of sin x plus cos x will be cos x minus sin x. This is the solution. Again, similarly, I can solve these two functions as a multiplication. Okay. Here, this is of the form. Okay. Here, again, f of x is equals to sin x into cos x. Here, there are two functions. There is a difference between these two functions. Here, there is an addition in between two functions, sin x and cos x. That's why I use u plus v whole dash formula. Okay. Or here I can use, here there are two functions. I will take this function as a u and this function as a v. Okay. Now, first function and second function, differentiation of f of x will be Take it differentiation of first function. First have to differentiate the function. Differentiation of sin x. Okay. I will keep constant of second function, that is cos x, plus again differentiation of second function. I will take the differentiation of second function and keep it constant of the first function. That is equals to differentiation of sin x will be cos x into cos x plus differentiation of cos x will be minus sin x, and differentiation of sin x, sorry, the constant will be sin x only. Cos x into cos x, that's why cos square x. Here plus into minus, minus differentiation of sin x into, sorry, sin x into sin x, that is sin square x. Therefore, multiplication of sin x into cos x will be cos square x minus sin square. Here there is an addition. Okay, cos x minus sin x. Now we will discuss the problems. Again, some examples. I will take another 2-3 examples here. Okay. Now again, there is a one example. Function f of x is equals to sine of root x. Okay. Differentiate with respect to x. If we know the formula of sine x, but we don't have sine root x, f dash of x is equals to, we know that differentiation of sine of root x. Okay, but we don't have sine root x, but we know that differentiation of sine x. Okay, it can be again in place of root x. I will simply taking the sign here, have to differentiate from left hand side to here. Okay, first differentiate sine function, keep it sine of root x, keep it sine of root x, again into differentiation of, in place of x we have root x, that is root x. Okay, differentiation of root x. Now I will take differentiation of sine root x will be cos of root x into differentiation of d into root x by root x. Differentiation of root x, what is the value of root x? 1 divided by 2 into root x. Okay, 1 divided by 2 into root x. Therefore, differentiation of f of x will be cos root x divided by 2 into root x. Okay, now we will discuss the example problems. Okay, first one, exercise 5.2. Differentiate the function with respect to x in exercise 1 to h. Okay. Here, I will consider the 5.2. First one. Differentiate the function with respect to x in exercise 1 to h. Here, the first function is let f of x is equals to sine of x square plus 5. Okay. Differentiate with respect to x. Okay. Here, differentiation of f of x will be f dash of x. Again, I will take like this. First differentiation of sine x. Then before going to that, I will write an differentiation of sine of x square plus 5. Okay. Now, differentiation. First have to differentiate the sine function. Differentiation of sine will be, that is cos x. Okay. In place of cos x, we have x square plus 5. That's why I am taking again differentiation of the x values. What is that? X square of 5. Okay. Now again differentiation I will take for x square 5. Here differentiation of x square, already we know that the differentiation of x to the power n is equals to n into x to the power n minus 1. Here replace n by 2, that is x square is equals to wherever n 2 into x to the power 2 minus 1, that is 2x. That's why I have written differentiation of x square by 2x here. 2x into differentiation of constant will be 5. Therefore, f dash of x is equals to 2x into cos of x square plus 5. This is the solution of the first problem. Okay, I will move on the second one. That is differentiation of here the function. Okay, here the function is f of x is equals to cos of sin x. Cos of sin x. Here again we will differentiate from this side only. Okay, again differentiate with respect to x. Other than x, all the values will be constant. Here f dash of x is equals to differentiation of cos, that is minus of differentiation of cos will be, I will take here minus of sin x. Differentiation of cos x will be minus of sin x. In front of x we have sin x. Okay, that's why I will take again differentiation of sin x. Now take it as minus sin x sin of sin x into differentiation of sin x will be cos x. Okay, here cos x. Therefore, differentiation of cos of sin x will be minus sin into sin x into cos x. Okay, this is the solution of the second one. Now, let's move on the third problem. Differentiation of sin of x plus b. Okay, here let the function f of x is equals to sin of ax plus b. Okay, I will differentiate with respect to x. Okay, here f dash of x, again I will consider the differentiation from like this only. First I will differentiate the outer function, that is sine. Okay, differentiation of sine of ax plus b. Differentiation of sine function, that is cos of ax plus b. In place of x we have ax plus b. That's why I'm taking again differentiation of ax plus b. Okay, here cos of ax plus b into differentiation of a into x. A will be the constant value, differentiation of x will be 1, and b is the constant, differentiation of constant 0. Okay, I will take on here cos of ax plus b into a into 1 a. That's why the result is a into cos of ax plus b. F dash of x is equals to a into cos of ax plus b. This is the solution of the given problem. Now, the question number 4. I will consider f of x is equals to sec of tan of root x. Again, now we consider from like this only. First have to differentiate sec function, then tan function, root x function. Okay, but we not discuss the sex and tan x formulas. Okay, here I will in the standard formulas. Okay, that is differentiation of sec x. Okay, I will give the formulas. Okay, d by dx of sec x will be differentiation of sec x will be sec x into tan x. Differentiation of sec x will be sec x into tan x. Again, by the standard formula, differentiation of tan x will be sec square x. Okay, these are the basics standard formulas for differentiation. Differentiation of sec x will be sec x into tan x. Differentiation of tan x will be sec square x. Okay, I will take on here differentiation with respect to x. Differentiate with respect to x. Now, f dash of x. First, I will differentiate sec function. Okay, differentiation of sec of tan of root x. I will take sec function. Differentiation of sec will be sec x and tan x. Okay, here what is the value of x? Here they given tan of root x. Okay, again tan x in front of x we have tan of tan root x. Then again we don't have any x here. That's why again differentiate d by dx of what is the value of differentiation? That is tan of root x. Okay. Now the value is sec of tan root x into tan of tan root x. Again differentiate tan of x. Here differentiation of tan. What is that? Sec square x. Here in front of x we have root x. So that's why I am taking again differentiation. You have to differentiate up to we have the x value. Okay. Again I will consider same sec of tan root x, tan of tan root x into sec square of root x. Differentiation of root x will be 1 divided by 2 into root x. Okay. Differentiation of root x will be 1 divided by 2 into root x. Okay. This is the solution of the function f dash of x. Because if in front of x, differentiation of x will be again 1 only. Therefore, differentiation of sec of tan of root x will be sec into tan root x, tan of tan root x into sec square root x divided by 1 by 2 into root x. When you are going to again, you have to practice more. Okay. When you solve different examples, you get better idea about the differentiation. Okay. Now, differentiation. Okay. Here we have to use the quotient rule. That is u by v. Okay. Here u is the functions. Okay. The formula is u by v dash. What is the formula? So, have to differentiate first function and keep constant as the second function minus differentiation of second function, that is v, take it first function common divided by v square. Okay, that's why I'm solving by using that. Okay, I'm using the formula. Keep replace u as a sine of x plus b, v as a cos of sine x plus c. Now, let f of x is equals to sine of ax plus b divided by cos of cx plus d. Again, differentiate with respect to x. Then f dash of x is equals to, here first by using this formula I have to differentiate the first function, that is differentiation of u, that is sine of ax plus b, and keep constant as a v function, that is cos of cx plus d, minus again differentiation of second function, that is cos of d by dx of cos of cx plus d into constant as a sine of ax plus b whole divided by v square, that is cos square of cx plus d. Now I can solve here. Differentiation of sine function, that is constant cos. Differentiation of sine will be cos of ax plus b. In place of x we have ax plus b. That's why I will differentiate again ax plus b into cos of cx plus d minus differentiation of cos function, that is minus of sine cx plus d into, in place of x we have cx plus d, that's why again I have differentiate d by dx of cx plus d into sine of ax plus d, again whole divided by same cos square cx plus. Now I will written here cos of ax plus b into differentiation of ax plus b, differentiation of a, keep it as a constant, and differentiation of x will be 1. Again b will be constant into cos of cx plus d, minus into minus it becomes plus sine of cx plus d into differentiation of cx plus d will be c. Here c is a constant. I will take here x is differentiation of x will be 1. Now constant differentiation of constant will be 0. Again sine of ax plus b whole divided by cos square cx plus d. This is the solution of the given function. Okay, this is the differentiation of the given function. Okay, now the next one problem, question number 6. Okay, I will solve the question number 6 here only. That's why I will erase this problem. So I have to declare once I will. Okay, here the question of the form. Okay, the function of the form u by v. Okay, here sin x and cos x. These are the two functions. So of the form u by v, I can use the formula u by v formula. First function I will differentiate. Okay. In that first have to differentiate the first function as a u. Again keep it as a v minus of. Take differentiation of second function and first function keep it constant, whole divided by b square, that is cos square cx plus d. Now differentiation of sin x will be cos of some value, that is ax plus b. We don't have complete x, that's why I will take again differentiation d by dx of ax plus b into cos of cx plus d as it is, minus differentiation of cos function, that is differentiation of cos will be sin x. Okay, in place of x we have cx plus d, that's why I will take again differentiation and keep sin of ax plus b as constant. Again, differentiation divided by cos square of cx plus d. Here, a cos of ax plus b. Differentiation of ax plus b is equals to a, and keep it as constant. Minus into minus get plus sine of cx plus d. And differentiation of cx plus d, we have c sine of ax plus b. Keep it as constant. Again divided by cos square cx plus d. Up to this much, this is the solution of the given functions. Now, move on the next one problem, the question number 6. Okay, here I will connect the function f of x is equals to cos of x cube into sine of whole square x to the power 5. Okay, now I will take cos of x cube as a u function, and this is as a, we'll know the product rule, that is differentiation of u into v is equals to, first have to differentiate first function and keep its second function constant, plus, because here there is a multiplication, that's why I keep it positive, then take second function differentiation and first function constant. This is the formula for product. Now differentiate with respect to x. Okay, again f dash of x is equals to, so I will differentiate the first function, that's why I'm taking d by dx of cos x cube into second function as a constant sine square into x to the power 5, plus I will again differentiate the second function d by dx of sine square into x to the power 5 into differentiation of sin square x into x5, and again second function as a constant, that is cos x to the power 3. This is the first step. Now have to differentiate now. First, from the method of differentiation, have to differentiate first cos. Differentiation of cos will be minus sine. Here in place of x we have x cube, that's why I am written x cube and again I will take the differentiation because there is no x, that's why I am taking again differentiation and keep constant as a sine square x to the power 5, plus, now here there is a sine square, so there is a power. Okay, that's why I am taking 2 into sine of, here first I will take 2 into sine of x to the power 5 in a whole value sine of x to the power 5, I will take it as x, so 2 into x, again differentiation of sine of x to the power 5. Now I can reduce the power of sine function, then I will take the differentiation of x to the power 5. Again keep constant as a cos x cube. Here, yeah, there is a some differentiation is left in this line. Okay, I will complete it. sine of x cube. Now, differentiation of x cube. What is the differentiation of x cube? That is 3 into x to the power 3 minus 1 will be 2 into sine of sine square of x to the power 5 plus 2 into sine of x to the power 5 and differentiation of sine x, that is minus of cos. Here in place of x we have x to the power 5. That's why I'm taking again differentiation, that is x to the power 5 into cos x cube. Again rearranging the terms here, minus sine x cube into sine of x square x to the power 5 into 3x square plus into minus minus 2 sine x to the power 5 into cos of x to the power 5 into differentiation of x to the power 5 will be 4 x to the power, differentiation of x to the power 5 is 5 into x to the power 4 into cos x cube. This is the solution of the given function because there is no differentiation left here. Okay, this is the solution. Now, I can move on the next problem. Okay, that is the question number 7. 2 into cot of root of cot of x square. So, let's consider the function. Let f of x is equals to here 2 into root of cot x square. Okay, again differentiate with respect to x. Okay, f dash of x will be, take it to as a constant, applying the differentiation d by dx of root of cot x square. Here, treat it as whole function as a x. There is 5 differentiation of root x. What is the differentiation of root x? That is 1 divided by 2 into root x. Okay. So differentiation of root x I will written as differentiation of cot of x square. Okay. I will written here in place of x, then 1 divided by 2 into x. So in place of x, what we written? Cot of x square. But we have 1 by 2 into x formula. But here cot of x square is there. That's why I will take again differentiation and cot of x square. Now, here this 2 get cancelled. We have 1 divided by root of cot x square. Differentiation of cot function. What is the function of cot? The standard formula of cot function is the standard function of the cot x. Differentiation of cot x will be minus, what is that? Differentiation of cot x will be minus cosec square x. Differentiation of cot x will be minus cosec square x. So, differentiation of cot I will replace by the formula cos x. Okay. Here in place of x we have x square. That's why I will take again differentiation d by dx of x square. Now 1 divided by root of cot x square into minus of cos x square x square into differentiation of x square will be, therefore differentiation of f dash of x will be, I will multiply here all the values 2x minus of 2x into cos x square divided by root of cot x square. This is the solution. What is that? Differentiation of 2 into cot x square is equals to minus 2x cos x square into x square divided by root of cot x square. Now, the question number each. Let the given function f of x is equals to cos of root x. Again, differentiate with respect to x. Okay, differentiate with respect to x. Now, f dash of x is equals to, from the like this. Okay, first differentiation of cos function. Differentiation of cos of root x. What is the differentiation of cos function? That is minus sine of. Here in place of x, we have root x. That's why I am taking d by dx of root x. Again, minus sine of root x. Differentiation of root x will be 1 divided by 2 into root x. Therefore, f dash of x is equals to minus sine of root x divided by 2 into root x. This is the solution of the given function. Up to this much, the basics differentiation of the differentiability we have discussed. Now